As the Earth's population continues to grow and our planet's resources become increasingly scarce, a critical question looms on the horizon. What will be the next great leap for humanity? For centuries, we have pushed the boundaries of exploration and innovation. But now, our sights are set on the ultimate frontier, space. With technological breakthroughs and ambitious missions underway, the dream of colonizing other worlds is no longer a fantasy of science fiction, but a tangible reality. Welcome to Space G.O.A.T. Join us today as we explore the possibilities, challenges, and groundbreaking efforts that are transforming our concepts of space colonization and opening up a new era of human existence. Over the next 10 minutes, we'll explore how our species is poised to become a spacefaring civilization. From orbiting hotels to red Martian dust, we'll cover the progress we're making, the massive challenges, and the incredible potential of space colonization. But first, why does this matter? Space colonization isn't just about adventure. It's about ensuring the long-term survival of our species, spurring technological innovation, and unlocking vast new resources. As we face increasing challenges on Earth, expanding into space offers solutions and opportunities we've only begun to imagine. Let's start our journey close to home, in low Earth orbit, or LEO. For over 20 years, the International Space Station has been humanity's toehold in space. But the future of LEO is far grander. Private companies are racing to build the first true space hotels, where tourists can experience weightlessness while gazing at our blue marble below. Axiom Space is leading the charge, having already sent private citizens to the ISS. They plan to attach their own modules to the station by 2025, eventually separating to form the first commercial space station. Meanwhile, companies like Orbital Assembly Corporation are designing rotating stations to simulate gravity, promising multi-week stays for up to 400 guests by the 2030s. The technical challenges are immense. Life support systems must be perfected, radiation shielding improved, and the psychological effects of isolation addressed. But solutions are emerging rapidly. Advanced recycling systems will allow 95% of water to be reused, while artificial gravity may mitigate bone and muscle loss. Economically, space tourism is projected to be worth billions annually by 2030. Imagine watching a sunrise every 90 minutes. Floating to a viewport to conduct cutting-edge experiments, then ending your day with a gourmet meal as you orbit the planet. This could be the daily life of a space hotel guest or researcher within the next decade. Beyond tourism, these stations will also serve as manufacturing hubs, leveraging microgravity to produce unique materials and pharmaceuticals impossible to create on Earth. Now let's venture further to Earth's celestial companion, the Moon. After a 50-year absence, we're going back. And this time, we're staying. NASA's Artemis program aims to establish a permanent human presence on the lunar surface by the late 2020s. The Artemis base camp will serve as a proving ground for technologies needed for Mars and beyond. China, too, has announced plans for a research station near the Moon's south pole by 2030. The Moon offers incredible resources. Water ice in permanently shadowed craters can be split into oxygen for breathing and hydrogen for fuel. Rare earth elements could be mined for use in electronics and green technologies. And helium-3, rare on Earth but abundant in lunar soil, could power future fusion reactors. But lunar colonization faces unique hurdles. The 2-week lunar night requires massive energy storage solutions. Lunar dust is abrasive and electrically charged, potentially damaging equipment and human lungs. And the Moon's weak gravity, just 1/6 of Earth's, will have long-term effects on human physiology we're only beginning to understand. Timeline predictions suggest a permanent crew of 4 to 8 astronauts by 2030, growing to dozens by 2040. Breakthroughs in 3D printing with lunar regolith could allow rapid expansion of habitats and infrastructure. Picture a lunar colonist's day, waking up in a lava tube shelter, donning a sleek spacesuit, and driving an electric rover to oversee robotic mining operations. Evenings might be spent in a communal dome, gazing at the distant blue Earth while discussing the latest supply shipment from home. Our next stop takes us to the rusty sands of Mars, humanity's first true step if we are to become an interplanetary species. SpaceX's Starship, designed explicitly for Mars missions, promises to revolutionize deep space transport. NASA and China both have plans for crewed Mars missions in the 2030s, while private ventures like Mars One capture the public's imagination. Mars offers a unique blend of challenges and opportunities. Its atmosphere, while thin, could be used to produce oxygen and fuel. Subsurface ice deposits could sustain colonies and eventually enable terraforming. The Martian day is only 40 minutes longer than Earth's, easing human adaptation. However, the obstacles are formidable. The journey alone takes 6 to 9 months with current technology. Radiation exposure during transit and on the surface is a major concern. The planet's low gravity and high CO2 atmosphere present long-term health risks we're still studying. Economically, Mars could become a scientific and technological powerhouse. Discoveries about the planet's geology and potential past life could revolutionize our understanding of biology and planetary formation. Novel materials and pharmaceuticals developed for Mars missions could have immense value on Earth. By 2050, we might see a self-sustaining Mars colony of several hundred people. These first pioneering humans will have the opportunity to forge a new way of life, which may be similar to living on Earth in some ways, but will undoubtedly be hugely different too. One only has to look at the wealth of books and films that have envisioned life on the Red Planet to see that it has captivated our collective imagination for many years. Life on Mars could be humanity's greatest adventure so far. Between Mars and Jupiter lies a belt of asteroids and an almost unimaginable wealth of resources. Companies like Planetary Resources and Deep Space Industries are already developing techniques for asteroid prospecting and mining. NASA's OSIRIS-REx mission successfully returned samples from asteroid Bennu in 2023, proving the feasibility of asteroid manipulation. A single metallic asteroid could contain more platinum group metals than have ever been mined on Earth. Water-rich asteroids could serve as refueling depots for deep space missions. And some asteroids contain rare elements crucial for advanced electronics and green technologies. The technical challenges are immense, but surmountable. Autonomous robotics and AI will be crucial for operations so far from Earth. New propulsion technologies like ion drives will allow efficient transport of materials, and space manufacturing techniques will need to be perfected to process raw materials in zero gravity. Economically, asteroid mining could be revolutionary. A single platinum-rich asteroid could be worth trillions of dollars. This in itself could present its own problems, with corporations or countries fighting over the ownership and rights. If we can get past these issues, a find like this could break resource scarcity on Earth, potentially ushering in a new era of abundance. By the 2040s, we might see the first commercial asteroid mining operations, with remote operators on Earth guiding swarms of mining robots around a distant asteroid, and astronauts overseeing automated refineries in the void between worlds. Who knows, maybe further into the future still, we might even have small colonies of intrepid humans living throughout the asteroid belt, drawn to these new frontiers by the promise and potential of the unknown. Our final stop takes us to the outer reaches of our cosmic neighborhood, the moons of the gas giants and beyond. While human colonization of these distant worlds may be decades away, robotic exploration is already yielding incredible discoveries. NASA's Europa Clipper, launched in 2024, will study Jupiter's ice-covered moon for signs of life. Meanwhile, concepts for floating cities in the atmosphere of Venus or settlements on Saturn's moon Titan are being seriously studied. The outer solar system offers unique resources. The abundant hydrocarbons on Titan could fuel future fusion reactors. The subsurface oceans of Europa and Enceladus might harbor exotic life forms with revolutionary biotechnology applications. And the low-gravity environments could enable megastructures impossible elsewhere. The challenges, of course, are extreme. The vast distances involved make communication and supply lines difficult. Radiation levels around Jupiter are lethal without advanced shielding, and the frigid temperatures require energy-intensive habitats and infrastructure. Yet the potential is mind-boggling. These worlds could serve as gateways for interstellar missions. They offer natural laboratories for studying extreme environments and the origins of life, and they represent the ultimate test of human adaptability and ingenuity. By the end of this century, we might see the first human outposts on the moons of Jupiter or Saturn. You can absolutely imagine researchers in heavily shielded habitats analyzing samples from subsurface oceans, or engineers maintaining vast arrays of fusion reactors powered by extraterrestrial resources. For everyday people, long-term habitation of these distant worlds may be even further in the future, but it is starting to look more and more possible. And it is almost certain that technological breakthroughs will come in the next decade or so, which will make it even more likely. As we've seen, the colonization of space is no longer science fiction. It's a near-future reality we're actively working towards. From orbiting hotels to Martian cities and asteroid mines, humanity is poised to become a truly spacefaring civilization. The challenges are immense, but so are the potential rewards. Space colonization promises not just scientific discoveries and economic riches, but a fundamental expansion of what it means to be human. As we spread into the cosmos, we'll gain new perspectives on our place in the universe and push the boundaries of human potential. Thanks for joining us here again. Please let us know your thoughts in the comments, and don't forget to like, share, and subscribe for more quality space content every week. The future of our species may well lie among the stars, and that future is closer than you might think.